So here we have question number 36, everyone. An object is placed at a distance of 80 cm from the screen. Where should a convex lens of focal length 15 cm be placed from the object such that a real image of object is formed? Now, after reading the question, we can have an idea, we can have a diagram, that is, this is screen, suppose. Here we place the lens and the object is at a distance x from the convex lens. The distance between object and screen is given 80 cm. Therefore, distance between lens and screen will be 80 minus x. So from here we can say that u is minus x, object distance. Image has been formed on the screen, so image distance v will be plus of 80 minus x in centimeter, and focal length of the lens given, that is 15 centimeter. So 15 centimeter. Convex lens have positive focal length. According to lens formula, we have 1 by v minus 1 by u, that is minus x, equals 1 by f. X and 80 minus x being the LCM, we have x plus 80 minus x equals 1 by 15. X cancel out. Cross multiplying gets you 1200 equals 80x minus of x square. So we are having a quadratic equation in terms of x. So x square minus 80x plus 1200 will be 0. Using the Sridharacharya method, we can calculate the roots of x. So x, therefore we can write 80 plus minus under root b square minus 4ac, that is 6400 minus of 4800 divided by 2, and after solving we will get the values of x as 60 centimeter and 20 centimeter, where x is the object distance. Now here we have to calculate where should a convex lens of focal length 15 centimeter be placed from the object. Means we have to calculate the value of the object distance, that is either 60 centimeter or 20 centimeter. Means both 1 and 2 are correct, so we will go with option number 4. Now let us proceed to the next question, that is question number 37. So here is question number 37. Refractive index of thin soap film of uniform thickness is 1.38. The smallest thickness of film that gives an interference maxima in the reflected light when light of wavelength 5520 angstrom falls at a normal incidence. Now we know very well, in thin films, for reflected light, the condition of maxima will be 2 mu t cos r equals 2n minus 1 lambda by 2. This is very much clear to us. Now according to question, the smallest thickness is clearly mentioned, so that's why we will put n equals 1 and we get 2 mu t cos r equals lambda by 2 directly. Normal incidence clearly mentioned, so r we have to put 0 degree. Therefore, we will get the value of t as lambda divided by 2 into 2 mu. Cos r will be 1. Putting the values from the question, we will get lambda as 5520 whole divided by 2 2s are 4 into mu, that is 1.38. After solving, we will get the thickness of film as 1000 angstrom. And after looking at the option, we can say that option number 3 is absolutely correct. So we will go with option number 3 only. Now let us proceed to the next question, that is question number 38. Now here is question number 38. An unpolarized light of intensity 64 watt per meter square passes through 3 polarizers such that the transmission axis of last polarizer is normal to the first one. If the intensity of emerging light is 6 watt per meter square, then angle between first two polarizer may be what? Now we know very well, after passing through the polarizer, the intensity reduced to half of the unpolarized light intensity. So suppose these are the three polarizers. This is polarizer number 1, let us assume. This is polarizer number 2, and this is polarizer number 3. Suppose if I am passing I naught intensity, then after first polarizer, the intensity remains of polarized light, that is plane polarized light, will be I naught upon 2. Now suppose the angle between polarizer 1 and polarizer 2 is theta, then according to Malus law, we will get I dash here, that is I naught upon 2 cos square theta. Now since it is clearly mentioned that polarizer 1 and polarizer 3 have 90 degree angle between their transmission axis, so the angle between polarizer 2 and polarizer 3 will be 90 minus theta, and according to Malus law, the final intensity I double dash, we will get I double dash as I dash cos square angle, that is 90 minus theta. Now putting the values, I double dash clearly given in the question, that is 6, I dash is I naught upon 2 cos square theta multiplied by cos square 90 minus theta will become sin square theta. Let's multiply 4 into 4, both numerator and to the denominator. We will get 6 equals I naught upon 8. 4 cos square theta into sin square theta will become 2 sin theta into cos theta whole square, that is 6 equals I naught upon 8 times sin 2 theta whole square. Now putting the value of I naught, we will get sin 2 theta whole square equals 6 8 ja, that is 48 whole divided by I naught, that is 64. 16 3 ja divided by 16 4 ja. Now finally we will get the value of sin 2 theta as root 3 by 2. Therefore 2 theta will be 60 degree and hence theta will be 30 degree. So the possible value of theta may be 30 degree, and after looking at the option we can say that option number 1 is absolutely correct. So we will go with option number 1. Now let us proceed to the next question, that is question number 39. Here is question number 39. Graph between stopping potential and frequency of incident radiation is shown in figure. The work function of material is nearly. Now we know very well, if the graph is plotted between stopping potential and frequency, then this will be the threshold frequency nu naught. So nu naught will be 1 into 10 to the power 14 Hertz. We have got the threshold frequency. Now we can write the work function phi as h nu naught. Putting the values, we will get phi equals h 6.6 into 10 to the power minus 34 into frequency, that is 10 to the power 14. Answer comes out into joule, but in options the unit used is electron volt. So let's convert it into electron volt. 1.6 into 10 to the power minus of 19, and after solving it we will get 0.414 electron volt, or approximately 0.42 electron volt. So when we go through the option, we can say that option number 2 is absolutely correct. So we will go with option number 2 only. Now let us proceed to the next question, that is question number 40. So here is question number 40. The electric current due to electron motion in nth orbit In of hydrogen atom is proportional to what? We know very well
the electric current due to motion of revolving charge given by I equals Q into nu, where Q is the charge, nu is the frequency. Now for revolving electron, I nth, where n is the orbital number, so I nth will be electronic charge multiplied by frequency of revolving electron in nth orbit, V nth. Now we know very well the frequency of electron revolving in nth orbit will be proportional to 1 by n cube. Therefore, electric current due to revolving electron in nth orbit, I nth, will also be proportional to 1 by n cube. So this is our result, and after looking at the option, we can say that option number 3 is absolutely correct. So we'll go with option number 3 only. Now let us proceed to the next question.